Length matching is a critical element of high-speed design, usually solved by carefully tuning the lengths of critical routes. This release sees extensive improvements to both single-sided and differential pair length tuning capabilities. Length tuning now supports all three popular tuning patterns: trombone, sawtooth, and accordion. If you're working with lower speeds or lower frequency signals, you can get away with trombone tuning. For the trombone patterns, the trombone area that the pattern is constructed within can be thought of as a sleeve. You'll notice that there are multiple 90 and 180 degree turns in this trace configuration. Using curves for these bends is more preferable than using a hard right angle in that it creates a smaller impedance discontinuity. There are a number of different movement and size change behaviors available, depending on where you click and hold on the sleeve. But this can be a poor choice for length matching in differential pairs if not used correctly. The second pattern added to Altium Designer 21 is Sawtooth Tuning, which uses a similar polygonal area within which the pattern is built. Here, we haven't used any smooth bends along the trace. These dimensions are used to minimize any impedance discontinuities along the length of the trace. And they're great in places where building an accordion is almost impossible due to the large number of objects near the track. Accordion tuning and trombone tuning are similar in that they both use a serpentine routing pattern. However, accordion tuning does not offset the serpentine pattern off to the side of the trace. Instead, it can be routed along the length of the desired signal trace. This is a better choice than trombone length tuning for high-speed signals on differential pairs, as you can maintain tight coupling along the length of the traces. In some cases, there isn't enough space to build an accordion, but in Altium Designer, it's possible to rotate the meander construction zone to maximize the area available.